In a previous episode, I answered the question, how do we know the age of the Earth? And in that episode, we learned about radiometric dating and how scientists use certain elements as clocks to date really old objects. Now, you may think scientists use a similar technique to determine the age of the universe, but there's just one little problem. When the universe began, there were no elements, and therefore no way to perform radiometric dating. So the question stands, how do we know the age of the universe? In order to figure out when it all began, scientists use two different methods. One, they study the oldest objects in the universe, because the universe can't be any younger than the matter it contains. And two, they measure just how fast the universe is expanding. That's right, it's getting bigger. Some of the oldest objects in the universe are stars, and it's known that a star's mass affects its brightness and lifespan. Larger mass stars burn brighter, but they also burn through their fuel more quickly. Stars with lower mass do not burn their fuel as quickly, and therefore live longer. For example, our sun will have a lifespan of about 9 billion years, but a star that is 10 times more massive than the sun will only burn for about 20 million years, while a star that has half the mass of the sun will burn about 20 billion years. These characteristics are similar for dense collections of stars called globular clusters. Stars in the oldest known globular clusters have been calculated to be between 11 and 18 billion years old. This wide range of potential ages comes from the difficulty in determining just how far away these globular clusters are, which also affects the estimates of their brightness and mass. This does, however, put a limit on the age of the universe. The universe cannot be any younger than 11 billion years old. And since it took some time after the Big Bang for stars to form, we can predict the universe is actually older than 11 billion years. Now let's talk about the universe getting bigger. This is where the real fun begins. Back in 1929, Edwin Hubble, the guy with the telescope named after him, noticed that all the distant galaxies around us were getting farther and farther away, which means the universe is expanding, similar to the way this balloon expands as I blow it up. As you can see, all the galaxies are getting farther and farther away from all the other galaxies. If we travel backwards in time, this expansion will reverse into contraction, and all the galaxies will get closer and closer to one another. Travel back in time far enough and eventually you'll reach a point where the universe is a point. So if you know the rate at which the universe is expanding, you can calculate back to when it was born and determine its age. In order to determine the expansion rate, known as the Hubble constant, scientists needed to know the composition and density of the universe, which was independently measured by NASA's Wilkinson microwave anisotropy probe and the European Space Agency's Planck spacecraft. Each of these spacecrafts mapped the cosmic microwave background by scanning the skies and collecting the oldest light from the farthest reaches of space, and used it to give a snapshot of the universe a mere 370,000 years after the Big Bang. NASA's WMAP spent 9 years mapping the universe, and in 2012 estimated it to be 13.77 billion years old, give or take a few million years. The following year, the European Space Agency released the data from the Planck spacecraft it gathered using instruments far more sensitive than had ever been used before, and it measured the age of the universe to be 13.82 billion years old. This is the most accurate measurement we have to date, and it's within the range calculated by NASA. It also fits the predictions made based on the oldest objects in the universe. So we currently have the age of the universe to be 13.82 billion years old. But let's put that into perspective. If a timeline of the universe was the length of an American football field, with the Big Bang at one end zone and the present day at the other, the ignition of the sun wouldn't take place until you got all the way to your opponent's 33-yard line. That's also the spot where the Earth forms about 4.6 billion years ago. Dinosaurs would only roam the Earth from about 1.5 to half a yard from the end zone. Keep in mind, that's 165 million years of dinosaurs. The first humans would only show up at just a few blades of grass away from the goal line. Within those few blades of grass, every person that ever existed lived out their lives. Every historical event you have ever heard of, from the building of the pyramids to the development of the internet, took place in less than 1/10 of an inch from the goal line. Wow, you see, that's the cool thing about science. It can help us describe events that took place over time spans much greater than we get to experience in a lifetime, and understand things that may otherwise seem impossible to understand. It's incredible just how much we have learned and figured out in that 1/10 of an inch. So stay curious, keep asking questions, and continue exploring the world around you, because there's still a universe full of questions, and we need you to help discover the answers. Thanks for watching. If the answer to this question just brought about more questions, good. That means you're thinking. Let me know what other questions you have in the comments below.